All right, we have the last of the story problems for the energy unit. This is going to be problem set 4, and it's going to be questions 6 through 11, it looks like. So, what I'll do is I'll go through and help you with the setups, and then from there you have to do the rest of it on your own and submit the work to Schoology. So to start off, let's just make sure that we have all of our formulas. We have work equals force times distance. All right, now all of our problems that we're going to have, we do not need to worry about the cosine theta, because we're going to say that if we have any movement, it's going to be parallel to the direction of motion, so we can leave that part out. Okay, then we're going to have power equals work divided by time. Now remember, power, it's going to be the same thing as saying force times distance over time, or we could have mass times acceleration times distance divided by time. It's all how we break the problem down. Are you given force? Are you given acceleration? Are you given work? So it's what you're given. That's why we use the guess method. We had potential energy, in particular gravitational potential energy. You had MAG, mass times gravity, that is the weight, times the distance. All right, so again, this could be we'll just do that. We'll have FW times D is what you can have. All right, so, and you can see if I move this over just a little bit, see it's very similar to what we had before, because you have force times distance equals work, and work equals the amount of gravitational potential energy you have after you've done the work. Okay, and then today's stuff, we're going to have kinetic energy equals 1/2 mv squared. All right, so at some point in time, we're going to have to utilize all of those equations. So let's start. We have number 6. Number 6, we have a 10 kilogram mass. All right, so we're going to start out putting down the givens. We have mass 6. My phone just went off, so it threw me. So we have 10 kilograms. It says that you have a velocity of 20 meter per second, and it says find its kinetic energy. All right, so this is what you should have. Some of you guys are not putting down all of the guess method, and I'm going to start taking points off if you don't put down the stuff. All right, so if I'm showing you, you've got it. You can put it down yourself. All right, so our formula here is 1/2 mv squared. Now, I'm going to work you through the first one just because I want to make sure that you understand what's going to happen with that v squared thing. So let's do this. We're going to have mass, 10 kilograms. The velocity, I'm going to put it in parentheses, because what you need to do, order of operations, you have to square that 20 first before you multiply it by the 10. Okay? So and then to finish it off, you have divided by 2 for that 1/2 part. So you plug that into your calculator and then get your answer. All right, let's go to number 7. Number 7 here says, hold on, I'm sorry. Let's go back here. We have part B. That's part A. Part B here, it says if the 10 kilogram mass moves at 10 meter per second, what is its kinetic energy? All right, so if you have kinetic energy, we'll just change our variables here. We don't need to write down everything again. We can just add the extra information in here. So we have mass is 10 kilograms. Now your velocity is 10 meter per second divided by 2. So for part B, you can get your kinetic energy in joules. It says, what is the ratio of A to B? So what you're going to do is you're going to take this answer right here, okay, and we're going to compare it to, let me change our color here, to this answer right here. Okay, so you put them next to each other. If they can be reduced, then you're going to reduce those. to see how many times this can go into that or that can go into this once you get your values, okay? And then for the last part of this, it says why. So just try to think of some reasoning as to why that value is what it is. All right, so you come up with some sort of reasoning why that would be, okay? Now we're ready to go on to number 7. Number 7, it says that what is the kinetic energy of a car? The car's mass is 1,600 kilograms, and it's moving at, for part A here, it says it's moving with a velocity of 30 kilometers per hour. All right. Let's see. Yeah, we'll be okay with this. All right. We'll have the kinetic energy is what we're trying to solve for. So kinetic energy equals 1/2 mv squared. Okay. So your kinetic energy here for A, we'll have the 1,600 kilograms times, and we'll put in 30 kilometers per hour. But let's change that to meters, okay? Because when we're looking at our base unit, we want to have meter per second. So we need a conversion in here. So we'll put in a times and then our conversion factor. 1 kilometer equals 1,000 meters. All right, so whatever that is, whatever that value comes out to be in your calculator, we're going to square that and then divide by 2. For part B, I'll put it over here. For part B, what happens if you have a velocity of 60 kilometers per hour? Now you might say, well, hey, the velocity is twice as much, so my kinetic energy is twice as much. Well, you may not want to go with that route, okay? Let's plug the numbers into your calculator and actually see what this is actually going to turn out to be. All right, so you're going to have the exact same thing that you had before. You'll follow the same procedure right here for part B. And then for the last thing that you have to do for part B is you have to put your ratio of those two together. And so part C, you have to have the ratio comparing your answer from this right here to your answer for part B right here. Okay, so you have to compare those just like with the last one. You have to compare them. And then for part D, why is there such a big discrepancy? What's different between those two velocities? Why are the kinetic energies so different? We're going to go to number 8. Number 8, it says you have a baseball and it weighs, so we're going to have weight, has 4.9 newtons. It says that it's going to hit a bat and it's going to leave with a velocity of 40 meters per second. It says calculate the ball's kinetic energy. All right, so kinetic energy equals 1/2 mv squared. So we're trying to solve for that. And nowhere in this do I have the weight. So what we have to do, and this is the reason why I gave you these formulas, we have to get the mass of this object. All right. So if we have to get the mass of the object, we want to figure out our FW. And I probably should have put this one up here also. I kind of did when we were looking at the mass times acceleration. Okay, but I didn't specify that that was our weight. All right, but you guys should know that, right? So number 8, we need to throw in one extra thing. We need to put FW equals MAG. So we're trying to find the mass of this, so that way I can plug it in right here. So I'm going to rearrange my equation. We have mass equals weight divided by gravity. The weight of this thing is 4.9 newtons. The AG is the acceleration due to gravity, so we should all have that memorized by now. We've used it enough. All right, now, whatever your mass is from this, we will then plug it in to our equation. All right, everything else is pretty standard, so I'm not going to go through and plug in all those values for you, but you should end up with something like this, okay? And then you fill in your numbers. All right, let's go to number 9. Number 9, we have an alpha particle with a mass of 4.7 times 10 to the negative 27th kilograms. And it's traveling at a velocity of 1.6 times 10 to the 7th meter per second. You're asked to solve for what its kinetic energy is. So kinetic energy, our formula, 1/2 mv squared. What you'll need to do now is plug in your variables and then using your calculator, come up with what the kinetic energy is. Number 10. It's going to be very similar to the last one. It says an electron with a mass of, we have 9 times 10 to the negative 31st kilograms, and it's moving at a speed of 2.5 times 10 to the 8th meter per second. We're trying to find the kinetic energy, so it is, like I said, exactly like the last one. So it's just more practice is what this is. So you plug in your variables, you use your calculator and come up with your answer. And we're on to the last one. Number 11 here says consider a 5 kilogram mass. So number 11, you have a mass of 5 kilograms. And the distance it's located above the Earth is 10 meters. Says, what is the potential energy of this? All right, so PE. Well, PE equals, from that formula list, MAGD. All right, we got the mass, that's 5 kilograms. We know the distance, that's 10 meters. All right, what's AG? That's the acceleration due to gravity. I'm not going to give that to you, you should know that. You can go ahead and put that value in here, that's meter per second squared. It's the same for anywhere on the Earth's surface. So you need to get your potential energy then, right here. It says how much potential energy does the mass lose if it falls 5 meters? Well, here's the deal. If we have part A, and you know that the potential energy formula is going to be the same thing, but you have, and the mass is going to be the same thing, right? 5 kilograms. I'm not going to give you AG. You should know that. Times the distance is now 5 meters. Okay, well, you can go ahead and get your potential energy when it's halfway down. Now, technically, you wouldn't have to take and do that formula because if you know what this value is right here, and you are halfway down to hitting the ground, this value should be half of the other. Okay? If it didn't come out that way, you got something wrong. We have what is the kinetic energy, or what kinetic energy does the mass have after it's fallen 5 meters? So with this, all right, with this part, let me change my color. For part C, if you know what this value is, halfway down, you have that value. What happened to the rest of it? What happened to the rest of it? Well, as you lose potential energy, so as this object falls, if it is halfway down, what should and you know what the potential energy is, and the potential energy up here was full. If this is half potential energy, what's your kinetic energy then? Okay, we have a conservation of energy. We're not going to create or destroy it. So if we know what our values are, that should add up to be this. Okay, It says, what speed does the mass have after it falls 5 kilometers? All right, so this is part D here. For part D, we're going to use the kinetic energy that you had from right here. All right, so we'll have kinetic energy, KE, equals mv squared. And I'm going to put it like this, divided by 2, or 1/2, whatever way you want to take and look at it. So we're going to go equals, the mass is 5 kilograms divided by 2, and then what you're trying to solve for is what that velocity is. So you're going to have to multiply both sides by 2, divide both sides by 5, and then get the square root of that value to get what your velocity is. Okay? And let me see if that's it. It looks like that's the last question. All right, so if you have questions, don't wait until after you turn to in if you got a question on something, because then your points are going to be lost and you don't get any help, you don't learn anything. So ask early. Do not hesitate. All right? Take care.